manufacturing and distributing world-class technologies for measuring and managing soil moisture, salinity, and temperature. Our expertise spans diverse fields, including research, mental management, underscoring our commitment to excellence and sustainability.
With over 2 million sensors sold in over 80 countries, we collaborate with a network of over 300 dealers addressing diverse climates, crops, and environmental projects worldwide.
Sentek was founded back in 1991 in the driest state, the driest continent on earth, right here in South Australia. Sentek's vision was to be globally recognised as best-in-class provider of soil, water and solute measurement and analysis with decision support. We are well on our way of recognising and reaching this goal.
Our growers who use Sentek technologies save on input costs, reduce waste, increase crop yield and quality, and ensure long-term sustainability. Supported by a global network of highly trained dealers, our representatives are based in the United States, Canada, Australia, New Zealand, Europe, Africa, Asia, South America, and the Middle East. And we work closely with the innovation of pioneers in the industry, including universities and institutes.
Our significant growth over the past few months is due to the hard work, dedication, and passion from each and every member from the Sentek team. We are not just a large business, but we also provide a sense of belonging to all the members of the Sentek team.
I'd just like to take this opportunity to thank all our stakeholders, our shareholders, our employees, our dealers, and our partners and suppliers. Thank you.
Oh, yes, boss from Sentek.
So that's just an introductory video of what we do, but we'll just quickly run by as to what exactly we do. We have been in the industry for 33 years. We started in 1991, and all we do is make the best soil profiling probes you will see in the industry. We have sold up to 2 million plus sensors across the globe. We measure moisture, temperature, and salinity, and we can measure it across all types of soils. We have over 250 plus dealers in our network. We supply our probes to 80 plus countries, from agriculture to environment, mining, and research industries. We have over 50 staffs in our company. Our head office is in Australia, Adelaide, South Australia, but we also have offices in US and Italy. And lastly, we are also ISO 9001 certified, which states the quality of our management system. We make sure that the quality of products we produce, the way we deliver it to you guys, the warranty, and all the troubleshooting we do for you is highly certified and well managed. So here's a snapshot of who we work with. So as you can see over here, you probably recognize one or two companies on this slide. We work with irrigation companies such as Netafim, Galcon, Wisecon, but we also work with fertilizer companies such as Yara, Dole. We work with different data loggers like Campbell Scientific, and our biggest customer is Valmont, which is a pivot company. They manufacture pivots and they're our biggest customer. So we work with all sorts of companies across the globe. Some of the markets that we target are in the agriculture market. That's the biggest market where our probes are used. We also do a lot of work in R&D. A lot of our probes have been used in published papers, which have been peer reviewed as well. We also do a little bit of work in landscape, and also we build long probes like those you see in the picture for environment and mining industries. So why is it even important to monitor irrigation and fertigation across your soil profile? What is the purpose of using our products? So we provide key insights into your crop production. Usually farmers want to know, especially those who have irrigation, they have a few things they want to know. They want to know when they can irrigate. They want to know how much they need to irrigate, and also what their irrigation schedule should be. These questions can only be answered if you use a product which can tell you your movement of moisture and fertigation across your soil. Additionally, there are many soil textures across the globe. Your farm will not have the same soil texture. It will have different soil textures. So it is important to identify your soil texture, and as it can affect your water holding capacity and your permeability as well. So only by having your soil probe, you'll be able to track the movement of water and fertigation across different soil types too. This is just a small snapshot of what our systems could look like. So you got your tree or your plant here with the root system, and you got your probes in here. Your probe will have sensors across these yellow arrows over here at different depths. Once they collect the data, it goes to the cloud and goes to our platform where you can analyze the data. So we tell you the movement of moisture, the moisture content in your soil, and it is important to know that because, as you can see by the study done by the United States Department of Agriculture, that your crop yield over here versus the number of stress days on the x-axis. If you have 15 days of stress, whether it's wet year or mild drought or severe drought, you can experience up to 50% yield loss. So if you're having a tough year, let's say you're having a drought, you want to know how much moisture is in the ground so you can then manage your irrigation system to ensure you don't get these losses. So now I'll just quickly run through some of our key products. So if we first focus on the hardware, we'll first focus on our soil moisture probes. The 4 main probes which I think can suit the Indonesia industry. Starting off with the EnviroScan, this is our research grade probe. As you can see here, we got our sensors over here. We got the access tube here where you put the sensors in. So the access tube protects the sensor. This is a customizable probe which can go up to 40 meters in length. So we use this in R&D. We use this in environment and mining industries as well. But we can measure moisture, temperature, volumetric ion content with this sensor. Additionally, this is the only sensor we have which can measure humidity as well. The beauty about this probe is that it's a customizable probe, and its sensor is a scientific grade sensor. So most of your research papers where you see our probes have been used, they usually use this sort of probe. The Diviner 2000 is pretty popular in certain Latin American countries and in India. It is basically a portable probe. As you can see here, we got the access tube installed, you got your metal rod in there, you place the probe in and it will give you your data immediately. Your data is collected by the LCD device over here, and this can be seen in Excel, in your Excel file as well. So this is not as popular for model right now, but it's still for some tender projects we get, they do request for a product like this, and this is the probe which we supply to them. The drill and drop probe is probably the probe that is the best suited for the Indonesian market. It is a probe which has the sensors embedded in it, and we can measure moisture, temperature, volumetric ion content. This is an easy probe to use. It's an easy probe to install, which can be installed under 5 minutes provided you don't have a clay soil. And this probe comes at various lengths, 30, 60, 90, 120 cm. So the sensors are located at every 10 centimeter increments. Lastly, we have the drill and drop Bluetooth. All the probes I mentioned before were cable probes. This is the probe we have, which is cable-less. So no cables, all you need is your phone to connect the probe and your phone, and you can download your data. So it is battery powered, can store up to 2,000 readings, which means you can go up to 40 days of collecting data. And it's very good for places where you're growing it in glass houses, for example, or areas where there's no reception. So you don't need to rely on your internet connection, you don't need a SIM card, you just need your phone, which has Bluetooth and this probe. So now I'll just talk a little bit about the telemetry and about our software, Max Live. With the telemetry, I'm only focusing on 3 main telemetries I think that suits the market here. So we have what we call the compact DTU. Essentially, it is a RS-232 modem, and as you can see here, this is in there we got the battery, the modem, the SIM card, and you have a 5-meter cable that connects up to the probe. So this will just be placed above the ground, so when you're harvesting your crops, you don't have to worry about it. If you're using machineries, you don't have to worry about it because it's not that high off the ground. Last year we came up with a DTU called the IoT DTU. It's an upgrade to our previous model plus DTU. And what we have over here is we have a solar panel here with a rechargeable battery inside. So your battery needs to only be recharged during the off-season once. Otherwise you can use the battery at least for 5 years. And this makes your whole system automated. You got your cable here, which starts off with a 5-meter cable, and then the
Ini di
data
Guru
gets
Tani
connected by the SIM
75
card,
channel.
uploads
Guru
to the
Tani
platform.
75 channel.
We recently launched the Nexus Blue. This was released last year. And it looks exactly like the IoT DTU, but the only difference is that it only connects to the Bluetooth probe. So if you have a Bluetooth probe, and let's say you want the data to be automated, you can't be bothered going to the field every time to download your data and upload it. All you need to do is install this DTU, which will connect to your phone and to the probe, and then it can automatically send data up. So it will just behave like your IoT DTU, except it's for the Bluetooth probe. So now we can also make the Bluetooth probe an automated one. We also integrate our probes to other systems. So like I mentioned before, we work with a lot of weather stations, a lot of other integrated companies, data loggers, irrigation systems. So some of the outputs we have are the Modbus for RS232 and RS485, but we also do SDI12 outputs as well. So if you have a data logger or a weather station, your customer has one, they don't want to buy our DTU, no problem. We can integrate to their system, and also we can do API transfer, so our API can go onto their platform or vice versa. So we make it very customizable and adaptable depending upon your customers. So now we'll talk a little bit about some of the features of a Sentek probe. So what are the features you can get? First of all, we have a unique installation technique, which is an undisturbed and a quick one. If you look at the probe over here, you can see that there's no gap between the probe and the soil. Now, most of our other competitors, you'll have to put what you call slurry to make sure that there's no air gaps. The problem with putting slurry is that you put in other soil materials, you put bentonite, which doesn't give you a true soil reflection. So your material here would be different to your soil, and then you wouldn't get good readings. But we avoid all of that by creating our own tapered auger, which is, as you can see up over here, the probe is thick at the top but narrow at the bottom. And the installation techniques is the same, go here is the same. So when you install it, all you have to do is insert it and there's no air gaps. So you don't have to worry about putting in anything into the soil to ensure there's any air gaps. Now that you have installed the probe, you have uploaded it up, now this is what our Airmax Live would look like if you were looking at one of the graphs. So I'll just briefly talk about it. If you look at the bottom, this is your overall soil water content. If you have a 90 centimeter probe, you'll have 9 sensors. It shows you the overall water content across the 9 sensors. So it's a sum of sensor 10, 20, and up to 90. Up here we have the individual sensors, so you can see your individual moisture content for each sensor depth. And above that we have ET over here. So usually you can have precipitation, rainfall, ET, voltage, volumetric ion content, whatever. We have many options, but for this case we have ET over here. So this is generally what a graph would look like on Airmax Live once you upload your data. So what can the graph tell you? So we have our algorithm which can tell you the root activity. So based on the movement of water, you can see these gray circles down the bottom. They will tell you that there's root activity. When you know where your roots are present and how deep they are, you can then manage your irrigation based on that. So this is what we're showing over here. If you look up here, you can see that there's green over here, which shows that there's root activity down to this level, and the irrigation reaches all the way down there, which is why it's green. That means that's good. However, in the next one, you can see that the irrigation doesn't reach all the way to the yellow line, and that's why it's red over here, which shows that the root hasn't received all its water. But then the grower fixed it the next time by making sure its irrigation reaches to the orange bit, and hence you get green here. So we can tell you where your root activity is happening, and then you can control your irrigation based on that. We can also tell you your duration of irrigation. So as you saw in the previous slide, you can see how deep your irrigation goes, but you can also see how long your irrigation goes for. That way you can control your irrigation to ensure that it only reaches to the particular depths you want it to. We can can also help you to identify crop water stress. So it is important to know how much water is in the soil and whether your plants have enough water to take up. So over here, what you can see is that there are these steps over here. These steps are indications that the plant roots are taking up water. But as you go towards to 29 Jan, you can see the steps are becoming smaller. This is usually an indicator that there's not enough water in the soil. So the grower here has put as a mark for stress, and so now he knows whenever the water content goes here, he can irrigate. So he can avoid having his crops being in a stress condition. We can also tell you when your soil is waterlogged. So waterlogging is probably what I think is worse, even worse than your crop being under stress, because it takes a long time for your soil to drain up the water. And especially if you have clay soils, it will take even longer. So you can see this example here, we have the grower who irrigated, and you can see there's too much water. So it's remained saturated in the soil because it's taken time for it to go down the soil profile. And then once it drains all the way down, now the plants are starting to take up the water under field capacity. When it irrigates again, you can see it's again saturated and comes down. It takes 48 hours in this situation for the water to come out of being in a saturated state. So that means for 2 days your plants are not able to function well because there's not enough air in the soil, but also there's too much water which can harm the roots. So here's another example of a graph which shows you that if you stay in a stress condition, over here red meaning you're stressed, too less water, blue meaning too much water, you can see down at the bottom, it's not clear here, but it's about 14% of the time the crop is stressed over here under heat stress, and 37.5% of the time it's in waterlogged stage over here. And you can see it has been waterlogged for almost 10 days before it goes down to being in a plant available water stage where the plants can take up the water. So once again, your crop is stressed here, starting to get infected, you irrigate too much, and then now your water content is saturating the soil, and then your plants are struggling. So over here in this graph, you can see 50% of the time you're spending in a stress condition. That's not good for your plants, and you can only identify that by understanding what is happening below the ground by using the probes. Now another thing we measure is what we call salinity. What we actually measure is volumetric ion content. This means we measure the number of ions in the soil, that's anions and cations. We don't measure EC. We are working on a calibration formula, but it's very difficult to measure EC because of soil compositions, especially in clay soil when cations of exchange capacity is very high. But we can tell you total ions. So how does a grower use this for fertilizer? As you can see over here, we got a 30 centimeter probe, and you got different ion contents over here. As soon as he applied his nitrogen fertilizer, the iron content has gone up. If you look down below at the water content, the irrigation was done the same day as well. So this grower decided he will only reapply his fertilizer application once it reaches to its pre-application concentration. So he can monitor the movement of the salts across the profile, and once it reaches to the same stage as before, he reapplies it again. So now you no longer need to just stick to the old method of applying once a week, once every other day, or whatever principles or practices you had, but now you can track the movement of your salts and then apply based on that. So I'll talk a little bit about the application of the probe. So we've seen the features. We can make sure that our crops are not heat stressed, they're not waterlogged. We can identify root activity, but how can this help to improve your crop as well? So in Australia, where we're from, we grow a lot of wine grapes in South Australia. And what our growers do over there is towards the end of their season, when they're about to harvest the crop, you can see that the water content is in the yellow and red zone. They're purposely stressing their crop. The reason they stress their grapes is because they're trying to increase the sugar concentration. If they increase the sugar concentration, they can sell it at a premium price. You can only do that if you know what is your water content in the soil, and so that you don't physically affect your grapes. If you don't know your water content in the soil and you stress your grapes out and the grapes get physically affected, you can't sell them at a high price anymore. So they avoid that by using the probe, sell it at a premium price. Once they harvest and sell it, they can then wash and saturate their soil. So they wash it away, all the fertilizers away, before they start again in the next season. So you can improve your crop quality, increase sugar concentration by using this method of irrigation. Additionally, we can also monitor the temperature across the soil. So if you have particular root diseases, or for example in this case powdery scape, which is a prominent disease in potatoes, you can avoid it by ensuring that your temperature is at a certain range. So you just have to be aware about your temperature, your irrigation, and you can manage according to avoid diseases as well. Lastly, we can customize your graph depending on your crops and your crop growth stages. Over here we have potato. As you can see, when your potato is germinating, the threshold for ideal irrigation, which is the green zone, is a lot smaller than when your potato is starting to flower and mature. Now, what a lot of growers do, potato growers do when they use our probes, is that when it starts to mature, they purposely start to stress their crop. The reason is they're trying to avoid any waterborne fungal disease in the soil, so they reduce the water content. And when the potatoes are ready to be harvested, they completely reduce the irrigation to kill the plants off quick so they can harvest. So, depending on the crop you have, we have many different crops. We can put different growth stages in there. You can change your irrigation based on each growth stage, so you can manipulate and manage irrigation accordingly. Lastly, I want to finish off with a case study to show you how these application of using these probes help. So the case study we'll be talking about happened in Italy. We will be focusing on the 2019 case study where processing tomatoes were made in 30,000 hectares of field in South Italy. So what was the trial site looking like? So in each site we had 2 Sentek probes, moisture probes of 60 centimeter. So that means we have 6 sensors in there at every 10 centimeters. And we made sure that we put the probes in similar soil types. They had the same variety, planting time, same tomato variety, fertilizer sprays, and it was drip irrigation. But the only difference is the control plot, we continued with the existing farm practices that were done by the grower, and in the second plot we used the Sentek probe to manipulate your irrigation based on the data you collected through AirMax Live. And what we see is that there's a huge difference in the way the irrigation worked. So I'll first bring your attention to the bottom graph. This is the Sentek graph, the Sentek probe, where the irrigation was managed based on the data Sentek probes could collect. What you can see is that majority of the time the water content is in the green, right? So that means it's in an ideal amount, there's enough water for the plants to take up and use. Now using these readings, which are considered the ideal amount of water, plant available water for the tomato plants, if you look up at the top, you can see that when they were in the control, that they were irrigating way too much. Most of the time they were in the saturated state. So this is not a good state for your tomatoes to be in. Obviously, you're spending a lot of water, energy, and more importantly, you could harm your crops. If you were to zoom into the graph, what you would see in the control graphs is that there are a couple of times there was under irrigation, so your water is not reaching your root content, but then there was a lot of over irrigation, which is showing that the water is making sure that the roots are only active in the top, but not even at the bottom. So your roots are not taking up all the water. It's not a good process for your crops to be in. However, if you look at the Sentek guided irrigation, you can see that that your irrigation rate is reaching to your crop root length. So your crops are taking up the appropriate amount of water without being stressed. By the time we harvested the crop, you can see that the Sentek crop, Sentek tomatoes had much better looking color tomatoes. There was higher bricks content for the tomatoes, so more sugar concentration, so they can sell at a higher price. But more importantly, also they reduce their water input. So visually you can see the difference between the control and the Sentek plots. So what irrigation savings were made? Okay, so first of all, Sentek probe had only 165 hours of irrigation compared to the control 230. And you could see that from the graph because most of the time the control was in a saturated state, whereas Sentek was in the ideal plant available water stage. Using 1.6 liters per hour and based on the water cost for irrigation, the amount of savings Sentek irrigation made was 1.48 megaliters. And if you translate that based on the 0.12 euros per meter cube, you can say that we saved almost 200 USD per hectare. And this is just on irrigation. So your irrigation cost reduced by $200 per hectare. Your crop yield looked better. And we haven't even spoken about energy costs that you save by reducing your irrigation. If we were to apply this to the whole tomato production, and now of course your soil type may be different, your irrigation rate might be different, but let's assume that if it was the same, you are making almost $6 million saving. Because he had 30,000 hectare of tomato production, 200 USD savings per hectare, you made $6 million of saving. So this is the sort of application our technology can bring to growers over here. Now, just very briefly, like in the 2019 study, which is the one I just explained to you, we saw greater color, reduced irrigation cost, and we made a saving of almost 200 USD per hectare. In the 2020 study, which I didn't talk about, we saw the similar benefits as well, with a much higher savings as well. So I would like to conclude with Sentek's mission. Our mission is that we believe that better water management decision comes from accurate and reliable data. This is why we pursue advances in technology to measure and monitor changes in soil, water, temperature, and solutes. So we have been making soil profiling probes for 34 years. That's all we specialize, that's all we do. We produce the highest accurate probes, highest resolution of data. We have the best AirMax live software for you to analyze your data. So that's what we focus on, because we want to bring the best technology to your production. And lastly, for your high quality culture production, you need and deserve the highest quality of products. Indonesia is known for growing, having many crops, variety of crops. It's big. There's a lot of need of technology and good technology in the industry. So we hope that we can find the right partners and right customers to work with. Thank you. So I can open the floor for questions. Does anyone have any questions? No questions? I don't see any questions. Okay, I think that's it from me. Thank you. Yeah, if you have any more questions or you want to meet, discuss about Sentek solutions for your production, come to our booth A1F309. Thank you.
Oke. Tadi presentasi dari Mr. Vikram dari Sentek. Iya. Yang mau bertanya, ini mbaknya mau bertanya langsung ke booth.